Aloha, Rich Alverson here, and this is ITS 388AL, and we are in Chapter 8, and we're learning about recursive programs, and today I'm going to review for us, give us some good hints on how to do the recursive greatest common divisor program, assignment 7. So I think I'm sharing my screen. Let me go take a look at Laulima here. Okay, this was assignment 6. And you recall it was the greatest common divisor program, and it was an iterative version. Okay, the first thing it did is it made sure that both of the operands coming in, x and y, this program finds that it returns the greatest common divisor between these two integers. And first it makes sure that their integers are positive, and then it proceeds to continually divide the x by y, and taking the mod, the modulo operation, and then moving the mod, shifting the mod into y, shifting y into x, and it continues to loop until it finds a y. It finds n, or the modulo, is equal to 0, which means the two are a divisor. It means which means they both, which means it divides by the denominator of the equation. And so when it's 0, then we know we're done, and it will return the integer just before the last modulo operation. And that is the greatest, that ends up being the greatest common divisor between the two integers. Okay, and so what we're supposed to do then for assignment 7 is to do the same function, except for we're going to use a recursive version of the greatest common divisor. And the way this recursive version works is it continually calls itself. It calls itself with the two same integers, x and y, and it looks to see if y is 0. If y is 0, then we are done, and x is the greatest common divisor that is returned. If y is not 0, then it does the same sort of shift, where it shifts y into the x position, and then for y it passes as an argument x mod y. And so that's the same thing basically it's doing in the iterative version, except for in the recursive version it calls itself, and eventually this x mod y will equal 0, and at that point the y comes in as 0, it returns the x, and then it basically returns the x here, and then it basically returns, and it keeps on returning, popping off the stack until we're back to the calling routine. All right, so this assignment is the same as the last one, except for we're going to replace the greatest common divisor function with the iterative version, with the recursive version. So I'm going to start with the version I had, the assignment 6 version. So let me see if I can find that. It's this program here, and I've opened it up. Yes, here it is. I've opened it up, and see, I am recording, and I'm recording the screen. Okay, so here is my assignment 6. It's the greatest common divisor program. It's from chapter 6. It's from chapter 7, and here is the algorithm, the iterative algorithm. We have a do while. This is a C version of it, and you recall we wrote this. It asks for the greatest common divisor. I think this was in a couple of videos ago. It asks for two integers. It displays this out twice, and then it does the computation and displays out the greatest common divisor, and it keeps on going until you just enter a return or enter a nothing in for one of the integers. And so here, you recall this program where we here we are actually displaying out the requests to enter the operands, and we look and we're using this write string and this read integer from page 169 and page 167. If what we read in is a 0, then we let's see, hold on a second. All right. So if we read in an integer and it's 0, we jump all the way to L2, which is way down here, and here we return. We display out the goodbye string, with the goodbye string, which is have a great day, goodbye. And same if we enter in a 0 or a nothing for the second operand, it does the same thing. If not, it's got two integers read in for the two operands, and it calls this greatest common divisor program with X in the EAX register and Y in the EBX register, and it calls it, and it's going to return the greatest common divisor in the EAX register, and it displays it out. It displays it out, and then it displays out this answer string, which is this thing, the greatest common divisor is, and then it writes the decimal value, calls character return line feed, and then it goes back and it asks you again for another pair of integers. Okay, and this greatest common divisor program is right here. It starts here, and we start out by pushing the EBX and the EDX register because we're going to use them. And then we compare X with 0, and that is comparing X with 0. If X is greater than or equal, oh, okay. Here what we're doing is we're checking to see if the integer that was passed in is negative. So we're basically taking the absolute value. This takes the absolute value of X and makes it positive if it's negative. This takes the absolute takes the absolute value of Y. It checks to see if it's negative. If it's negative, it negates it, makes it positive. And so now we've got two positive integers in EAX and EBX. That's X and Y. And then here we actually display out X and Y, and we don't need to do that in our new program. And then here's the loop that loops, and if we went through this last time, and you can see that it works when it's done. It keeps on looping till it's done, passes down through when it reaches 0, and it pops out EDX and EBX, returning the values to the same values that were there when this routine was called, and then it returns. So what we're going to do is simply replace this part here. We're going to replace this whole thing. Let's run this and see how it looks. Build a solution, and it succeeded. So we can start debugging, and we can enter in a couple of integers. Like, for example, if we enter in 15 and 25, we get 5. And you notice here it displays out the 15 and the 25, and that's basically what this is doing right here, displaying out EAX and EBX, although it's kind of reversed. We can do it again, minus 169 and I don't know, 39. Greatest common divisor is 13. You see, we see it makes them positive. All right, so and then we just hit the enter key. We got to put 0 in there. I guess so. All right, so, and then that ends it. Okay, so let's go and look at our problem here. This is the recursive version, so I'm going to copy this, and we're just going to, it's, you know, when we're doing these things, it's not super necessary that you fully understand the ins and outs of the logic of the program that we're trying to implement in assembly language. It's more or less a mechanical process, and the sooner you sort of see it as a mechanical process, the sooner you'll be able to just take a look at a higher level language program and reduce it to an assembly language program for whatever reason you'd like to do that. Okay, so I'm going to change this here. Change this to Chapter 8. It's a Chapter 8 assignment, which is recursive, greatest common divisors. Oh, I better save this as something else. Oh no, I did. I copied it onto my desktop, and so this is going to be my assignment 8, my assignment 7, Chapter 8. Greatest common divisor of two integers is the largest number between this greatest common divisor. Involves a recursive program described by the following C++ code. All right, so so this is all doing the same thing. Here we are reading in everything. Okay, this is the greatest common divisor part down here. And okay, so I'm going to use, let's see, hold on. I got to find in the textbook. Okay, we are in Chapter 8 here, and here's Chapter 8, page or section 8.4. We're going to be using this invoke. What did I just do? I didn't mean to do that. Invoke. Oh, okay. Let me find this again. Invoke. Can I just do this? Invoke directive. So the invoke directive, it's the same as the call, except for you're able to pass arguments after the procedure name, you know, separated by commas, and it will automatically do the pushes for you. Okay, and then when the program is done, it'll automatically pop. The return will automatically pop the stack. You know, return the stack to where it was when the subroutine was called. And so, for example, if we want to do something like this, where, see, we want to pass 3 operands to the dump array program, the way we would normally do it without invoke is we would first push the first operand. Actually, we push the last operand, push the second of the last operand, and push the first operand, and then we call the dump array program. That can be replaced with this, where we call the dump array program followed by the first operand, followed by the second operand, followed by the third operand, you know, separated by commas. And we're going to use this to pass our operands to the greatest common divisor program. They have to be passed on the stack because we have to retain their values as we call, as we recursively call the subroutine. So when we return these values, the stack and the values are returned to what they were before the subroutine was called. And so we need to have that, and then we have to have this proc directive up there to let the assembler know that we're going to be using this invoke this invoke directive here. And so if we go back to our program right here, so this is where we're going to use using a recursive algorithm. So it receives X and Y as parameters on the stack, and it returns X and returns the GCD in EAX. So let's see, up here. Here is where we're going to call it. So instead of doing this, okay, in this program, in the old one, we just had, EAX as one operand, EBX as another operand. Here, this first operand is display. Oh, never mind. Yeah, obviously the first operand. It's an EBX and EAX. Compare EX. Okay, this is checking to see if it's 0. We want to replace this call GCD where we actually want to pass the operands on the stack. So let's use invoke. I'm going to name this. I'm going to keep it the same name. Calculate GCD, and I'm going to pass it EAX because that's X, and EBX is Y. So what these do is this thing reads an integer into X, into EAX, and then if it's 0, it jumps out. Otherwise, it moves EAX into EBX, and that fills EBX. And then we call the same thing again to read the second operand, and that is going to get stuck into EAX. So at this point here, EAX and EBX contain X and Y. Actually, EBX is going to contain X and EAX is going to contain Y, but it doesn't matter if one is it doesn't matter if they're out of order. It corrects itself right away with the first modulo operation. All right, so this is going to call the GCD program, and when we're done with it, the result is going to be in EAX, and then this thing goes ahead and displays out the value in EAX, okay, which is what we want. So now let's go and finish writing this calculate GCD program. So here we are actually for proc we need to say what operands are coming in, and the way we do that is similar to the invoke. This goes hand in hand with the invoke, and we bring in X, and we might as well just call it X, is a D word, and Y is also a D word. Okay, and so this comes in. X and Y are parameters on the stack. The first thing we're going to do is we don't have to do this push and pop anymore. I think this worked. I think this is right. Let's move X into EAX. So we're going to move X into EAX, move X into EAX, and then we're going to move Y into EBX. So this is going to move Y into EBX. And then let's do our checking to see if we're going to negate business here. Let's leave this here, leave this here, leave this here, compare x and y. Okay, so this is going to negate x and y if one of them is negative. And then we're done with that. So we don't need, we don't need to, well, I guess we can leave this in here. This simply just displays out, this displays out x and y after computing the absolute value. So this is sort of an optional section right here. That's fine. We can leave a display that out. So when we're down here. And so the first thing let's do is let's I gotta bring down, I gotta show this thing in the right side here. I want to show this. All right, so first thing we're going to do is let's test to see if y is equal to 0. So y is the second operand that came in. If y is equal to 0, then we're done. Then, you know, x is already in EAX. X is already in EAX. Y is in EBX. This is going to revert. This is going to make them positive if they're not. This is going to display it out if they're not. Okay, so right here, let's first compare. We don't need. We don't. I'm just going to take all this out of here. I'm going to take this out, and right here is when we start. I'm going to compare if EBX, that's y, compare it with 0. The EBX is y up here. If it's 0, if it's equal to 0, jump if equal to where we return. I'm just going to name that L3. L3, and L3 is where we return. So I'm just going to go down here and put L3. That's where we return. If EBX is not equal to 0, then we're here. Okay. If EBX is equal to 0, then we return, and we return x because x is y. We are returning x. If EBX, if y is not equal to 0, if it's great, it's going to be greater than, because these numbers are all positive now. So if it's going to be greater than 0, so then we can then we want to, okay, so if we look at this, if x is greater than or equal to y, or y is equal to 0, x is going to be greater than or equal to y. X is going to be the bigger number, and y is going to not be equal to 0. So this is going to be true, and this is going to be true. And so at this point, we are going to let's do this division. Let's do this. Let's figure out what this operand is. We have to figure out what that is, and to do that, we are dividing EAX divided by EBX, and we're taking the remainder of it. To do that, to do the division, we have to first zero out EDX, because we're going to use the div instruction, and the div instruction, the dividend is EDX plus EAX, and the divisor is simply EBX. So we have to make sure that EDX is 0, so otherwise it'll participate in the computation. So it's going to move EDX. We're going to move 0 into EDX, and then we're going to divide EAX by EBX, and this basically, this let's see, let's put some comments in here. This is going to compare if y equals 0, and if it is, if equal, return. Otherwise, prepare for modulo operation. And this is going to divide. So this is going to put the remainder of x divided by y into edx. That's what, or EAX. Basically, the remainder of EAX and EBX divided by EBX. That's going to go into EDX. The remainder is going to go into EDX. The quotient goes back into EAX, and the remainder goes into EDX. Okay, and so right now at this point, we have EAX contains this thing. EAX contains the remainder of EAX divided by EBX. And so we want to pass EBX. No, we want to pass EDX as the second operand, and we want to pass EBX as the first operand, calling this routine again, calling it again. So to do that, we simply need to go invoke this program again, calculate GCD. And this time we're going to do the first operand is the old y. The old y. EBX hasn't changed at all, so it's the old y, EBX. And the second operand is this EDX. EDX. Okay? And so this is going to call calculate GCD on EBX EAX, which is the same as y, and this is the same as x mod y, if you remember. All right, and that's basically it. This thing is just going to call itself again, and it's going to come in, and it's going to keep on doing that. Each time the smaller second operand is going to get shifted over to the first operand, and an even smaller operand, which is the remainder of x divided by y, is going to be passed in as the second operand. And when it's done, it will hit this comparison of comparing if y is equal to 0. If y is equal to 0, then it just returns, and it's gonna keep on returning until it finally arrives up here, and it can display out the greatest common divisor. So we can run this. And we should have build. I wonder what it didn't like. Let me just run this, build this again. Okay, it failed. Now, why did it fail? Invalid character in file. I got some extra stuff in here. I don't know. I'm supposed to have comment, end of the comment, data section, code. This is fine. Greatest common divisor. Okay, 46. It's got some funny characters in here it doesn't like. Starting at 46. This is it. Doesn't need that. Call calc GCD. Oh, I know what I need. Did I put a proto up here? I need to put I need to tell it that we're doing this. Calc GCD proto, and it doesn't matter what we put, int x d word, comma y d word. Make this lowercase. All right, I think, let's see if that helps. Okay, I'm gonna have to figure out what's going on here. Hold on. All right, the problem was I was mixing up my languages again. This is not a comment. This is a comment. And so the hashtag meant something. So anyway, now when we build, we get succeeded, and we can execute. And we should get the same answers. Let's try a -169 and 26. And we see the XY divisions, don't we? Let's try 125 and 45. So the first thing that happens is they get flipped, and then we see that as it continues to call each other, it goes down, and the last thing we do is 5. We do 10 divided by 5, and the remainder is 0, obviously, and so that's why the 0 comes in, and then that gets passed back, and the 5 ends up being the greatest common divisor. Anyway, so that's how easy recursion is, and so you should have enough here now to be able to complete the assignment. So I hope that helps, and next week we'll start chapter 9. Thanks for watching.